In this video, we're going to have a look at what happens to the perimeter and area of two-dimensional shapes when we double the dimensions. Here we have a rectangle of which the length is 3 and the breadth 4 units. The perimeter of this rectangle is 14 units and its area is 12 units squared. Now I'm going to enlarge this rectangle in different ways. Firstly, I'm going to double all of its dimensions. This means that its length of 3 is going to double to 6 and the breadth of 4 will now be 8. So the new rectangle will look like this with all the dimensions doubled. And if we now go and determine the perimeter of the new rectangle, we have two sides of 6 and two sides of 8, which will give us a perimeter of 28 units. So from this we can see that when all the dimensions are doubled, the perimeter of the shape will also double. Now let's see what this doubling of dimensions will do to the area of the shape. The area will now be 6 times 8, and that will give us 48 units squared. So here the area wasn't simply doubled, because double 12 would have given us 24. But if we take the 48 and divide this by 12, you will see that in actual fact this area has become 4 times bigger. This can also be seen on the sketch. Here you can see that 4 of the original rectangles can fit into the new bigger one. So here we saw that when all the dimensions are doubled, the perimeter will also double and the area will become 4 times bigger. This 4 comes from the doubling of the dimensions squared. And the square is because we are busy with area, and area is units squared. Let's now have a look at what happens when we only double one of the dimensions. So the 3 units length will stay 3 and our breadth will become 8. What influence will this have on the area and perimeter? If we calculate the new perimeter, we still have two sides of 3 units, but now we have two sides of 8 units, and that gives us a new perimeter of 22 units. Because we didn't double all the dimensions, the perimeter also didn't double. It was simply lengthened by the extra 4 units at the top and bottom. So this time the perimeter is simply 8 units bigger. If we have a look at what happened to the area of the new shape, we can already see by looking at the sketch that there are now 2 of the original rectangles fitting into the new shape. So the area should double. If we go and calculate the area, we have a rectangle that is 3 by 8, and that gives us an area of 24 units squared. And this time that is exactly double the original area. So in our first example, both dimensions, length and breadth, were doubled, and that meant that our area was doubled twice, so it became 4 times bigger. In our second example, only our breadth was doubled, and that caused the area to double. Example 1. If the sides and height of a given parallelogram is doubled, a new, bigger parallelogram is formed. Calculate the perimeter of the new parallelogram. We already know that the 2 pairs of opposite sides of a parallelogram are equal in length, and that we have one side of 20 centimeters and the shorter side is 13 centimeters. For the new parallelogram to form, all the dimensions are doubled. So our 20 centimeters will now be 40, the 13 will become 26, and the height of 12 will now be 24. So for the perimeter of our new shape, we have 2 sides of 40 centimeters and 2 sides of 26. This will give us a perimeter of 132 centimeters. Question B. Calculate the area of the new parallelogram. For the area of a parallelogram, we have the formula base times perpendicular height. In our bigger parallelogram, our base will be 40 centimeters and the perpendicular height is 24. That gives us an area of 960 centimeters squared. Example 2. The radius of the given circle is doubled to form a new, bigger circle. Calculate the area of the original circle in terms of pi. The radius of the original circle is given as 3 centimeters. To calculate the area of a circle, we use the formula pi times radius squared. So here we'll have pi times 3 squared, and that gives us 9 pi centimeters squared. Question B. Calculate the area of the new circle in terms of pi. So still we make use of our formula pi times radius squared, but now to form the new circle, the radius has doubled. So we will have pi times 6 squared. And squaring 6 will give us 36 pi. Question C. Calculate the ratio of the area of the original circle over that of the new circle. We've just calculated that the area of the original circle is 9 pi and that of the new circle is 36 pi. Pi divided by pi is 1, so we can simplify this to a ratio of 1 over 4. This means that the area of the new bigger circle will be 4 times that of the original circle.